Okay, class, let's take a look at the last of the radiation laws. Basically, this is known as Wien's displacement law. And Wien's displacement law allows us to calculate the wavelength of maximum emission for an object based on its temperature. So an object will emit radiation energy in a range of wavelengths, and so this particular law lets us predict or calculate the one wavelength that this object emits more of than any other. Okay? And so again, we'll use the sun and the earth as an example. And so if we remember that the temperature of the sun is approximately 6,000 Kelvin, the temperature of the surface of the sun. And so if we want to calculate the wavelength of maximum emission, so we use lambda, which looks kind of like a giraffe. It's a Greek letter to represent wavelength. And we're looking at the maximum wavelength emitted by the sun. Okay, this one's a really simple equation. It's just 2,897 mu, which is for microns, K for Kelvin, divided by the temperature of the object. In this case, it's going to be the sun. So this will be 2897 mu K divided by 6,000 Kelvin. So the kelvins will cancel out, and we're left with 0.483 microns. Now that's the wavelength of maximum emission for the sun. I'm going to draw another figure coming up in the next video that will help you understand that hopefully much better. Okay, so that's the maximum wavelength of maximum emission for the sun. What about the wavelength of maximum emission for the earth? Okay, so we know that the temperature of the earth, again, if we're rounding up, is 300 Kelvin. Okay, so the wavelength of maximum emission for the earth will be the constant 2,897 mu K divided by the temperature of the earth. Okay, so that's 2,897 mu K divided by 300 K. Okay, and this comes out to 9.66 microns. Okay? So now, another question we could ask is, in what wave band basically, what kind of radiation are we talking about with these wavelengths of maximum emission? So in what wave band do the wavelength of maximum emission for the sun and the wavelength of maximum emission for the earth fall? Okay, so in what wavelengths are these? What kind of radiation is this? Okay, so let's draw a number curve or a number line here. Okay, and on our number line, just going to put two numbers. Okay, so we'll put one here and one here. All right, and those two numbers are 0.4 microns and 0.7 microns. So if you remember from a previous discussion that the range of wavelengths that encompass the visible radiation is a very small range. It's only 0.3 microns. And so this is where we find visible radiation. Okay, and that is between 0.4 and 0.7. So around 0.7, this is where we have red. Around 0.4, this is where we have violet. Okay, and then this is where Roy G. Biv comes from. So red, orange, yellow, green, blue, indigo, and violet. Okay, and so any wavelength that is bigger than 0.7 microns, this will fall in infrared radiation. And anything that is smaller than 0.4 microns, this will be ultraviolet. Now, when you look at the terms, ultraviolet radiation, when you look at the terms, this should make complete sense. So you've got visible radiation that goes from 0.4 to 0.7 microns. 0.4 is ultraviolet. So if you go shorter than 0.4, you go from you go from violet into ultraviolet. Okay? And on the other end of the visible scale, at 0.7 microns, you have red. And if you go bigger than 0.7 microns, now you're in infrared. Okay? So if we take a look at the two wavelengths of maximum emission, okay, so what wavelengths of energy do the sun emit, and what wavelengths of energy does the Earth emit the most of? Okay, and it turns out that 0.483 microns falls in the visible wavelengths. Okay, and in particular, 0.483 is kind of in the bluish to green range, so kind of a blue-green. So you might have heard that the Earth is the big blue marble in the sky, okay, or in the solar system, and that's based on, part of it is based on the energy that is given off by the sun, the maximum wavelength of maximum emission. Now the Earth's wavelength of maximum emission is 9.66, so that's way out here. Okay, and I'll put it way out here at this scale. Now, infrared radiation, the range goes from about 0.7 microns way out to 100 microns. Okay, and so here we're looking at 9.66 microns is the wavelength of maximum emission. So this scale will continue on this way. And so the whole point here is that the wavelength of maximum emission for the Earth actually falls in the infrared wave band. Okay? And so, in fact, the Earth only emits infrared radiation. Okay? The sun, we said, emits all 7 forms of radiation. Okay? But most of it's going to be invisible. 43% of the solar energy that reaches the top of the Earth's atmosphere is in the form of visible radiation. 49% of the solar radiation that reaches the top of the Earth's atmosphere is in the form of infrared radiation. Okay? So, but the wavelength of maximum emission for the sun is actually in the visible wavelengths, and we calculated it as 0.483, kind of in that blue-green color range. And the wavelength of maximum emission for the Earth is 9.66 microns, which puts it in the infrared radiation. Okay? So there's one more figure I want to draw for you. It'll be on the next video, and hopefully it will help you piece together everything that we've talked about on, in this video and actually the previous video.